Hello viewers, welcome to Physics Facilitator. So in today's class we are going to start one-shot sessions of class 10 physics, and in this session we are going to discuss chapter 1, that is reflection of light at curved surfaces. So basically we have two surfaces of mirrors, right? One is plane surface mirror and another one is curved surface mirrors, and these curved surface mirrors are called as spherical mirrors. Okay, so these spherical mirrors are further divided into two types, concave mirror and convex mirror. So first let us understand what is concave mirror. So to understand this, let us take an example, like let us take a round shaped or sphere shaped thin mirror. After taking this, let us polish the inner side of this thin sphere shaped mirror so that it becomes smooth. Okay, and after that let us apply mercury on the outer part of this mirror. Okay, after doing this, let us cut a piece from this whole sphere. So how that piece would look like? It will look in this way, right? So after doing this, let us make a ray fall onto this mirror. So what will happen? Whenever a ray is falling onto the mirror, it will be reflected back, right? So definitely this ray will also reflect back, right? Again pass another ray onto this mirror. What will happen? This ray will also reflect back. Again pass another ray. What will happen? It will also get reflected. So what is happening here? The reflected rays are meeting at one point. So they are converging to one point. So this mirror is also called as converging mirror. Okay, so concave mirror is also called as converging mirror. Why? All the reflected rays are meeting at one point. That is, they are converging to one point. So this mirror is called as converging mirror. Okay, so what about convex mirror? Let us see what is convex mirror. Okay, let us take same a thin sphere shaped or round shaped mirror. After taking this, here we are doing in reverse manner. Okay, here we are polishing the outer side of this mirror. Okay, we are polishing this part, outer side of this mirror, and we are applying mercury in the inner side of this mirror. In concave mirror case, what we have done, we have polished the inner part of that mirror and we have applied mercury on the outer part of that mirror. In convex mirror case, what we are doing, we are polishing the outer part of this mirror so that the outer part becomes smooth, and we are applying mercury in the inner part of this mirror. Okay, after doing this, let us cut a piece from this whole sphere. So how does this piece look like? It will look in this way, right? Now let us pass a ray onto this mirror. So what will happen? Definitely it will get reflected back. Again pass another ray onto this mirror. What will happen? It will also get reflected. Again pass another ray onto this mirror. It will also get reflected. Again pass another ray onto this mirror. It will also get reflected. So what is happening here? Every reflected ray is diverging in different directions. They are not meeting at one point. So this mirror is also called as diverging mirror because the reflected rays are diverging from each other. They are not meeting at one point. So this mirror is also called as diverging mirror. Okay. Okay, so this is the basic difference between concave and convex mirror. So concave mirror is a converging mirror, that is the reflected rays are converging to a one point, so it is called as converging mirror, and convex mirror is a diverging mirror because the reflected rays are diverging from each other in different directions, so this is called as diverging mirror. Okay, so now let us see what is pole, center of curvature and focus and principal axis in concave and convex mirror. First, let us see what are they in concave mirror. So, first, pole. What is pole in concave mirror? The midpoint of this mirror is called as pole. The pole is denoted with letter P. Okay, and you know every circle has a center, right? What example we have took about this concave mirror? We have took a round shaped sphere. So this round shaped mirror definitely will have a center, right? So this center belongs to every part of this circle, right? So this center belongs to this part of this circle also. So this center is nothing but it is a center of curvature for this mirror, concave mirror. Okay, and another point is whenever we are extending normals from this incident rays, they all meet at one point. That point is called as center of curvature. Okay, so I am extending the normals from this incident ray. So they are all meeting at one point. That point is called as center of curvature, and center of curvature is denoted with letter C. Okay, and now let us see what is focus in case of concave mirror. Okay, so all the reflected rays are converging at a point, they are meeting at a point, so that point is called as focus. It is denoted with letter. Yes, another way we can say as all the reflected rays are focusing at one point. That point is also called as focus. Okay, and the line passing from pole to center of curvature is called as principal axis. Okay, so this line which is passing from pole to center of curvature, this line is called as principal axis. So these are pole, focus and center of curvature and principal axis in case of concave mirror. Next, let us see what is convex mirror. Okay, in convex and concave mirror, pole and center of curvature are same for both mirrors. Here also pole is the midpoint of this mirror. So here is the pole P. And what is the center of curvature? Same thing. This sphere also have a center, right? So this center also belongs to every part of this circle. So this center belongs to this part also. So here the center of curvature is also same, right? Next, focus. So what is focus in this case? If we extend the lines from this reflected rays, then all the reflected rays will meet at one point. Okay, all the extended lines drawn from these reflected rays will meet at one point. So this point at which all the reflected rays are meeting, that point is called as focus in case of convex mirror. So the basic difference between concave and convex mirror in case of focus is, in concave mirror case, the reflected rays look like they are going inside the focus. They are focusing into the focus point. But in convex mirror case, the reflected rays look like they are coming out of this focus. So this is the pole, focus and center of curvature in case of convex mirror, and the principal axis is same. The line drawn from pole to center of curvature, this line is called as principal axis. Okay, so this is pole, focus, center of curvature and principal axis in both concave and convex cases. Next, rules to draw ray diagrams. So what is ray diagrams? Ray diagram is nothing but this is a ray diagram. Okay, so there are some rules to draw ray diagram. So let us see what are they. Okay, first one. All the rays that travel parallel to the principal axis will get reflected in such a way that they meet at a point called focus. So this is in case of concave mirror, right? So what he is saying, let us first draw a concave mirror. This is a concave mirror, right? So definitely it will have a principal axis. Okay. So what he is saying, whenever a ray travels parallel to the principal axis, will get reflected, again pass another ray onto this mirror, it will also get reflected back. So what is happening? These rays are meeting at one point. So that point is called as focus. So every ray which is traveling parallel to the principal axis will get reflected in such a way that they all meet at one point, that is called focus. Okay, so this is in case of concave mirror. But in case of convex mirror, what will happen? Let us draw a convex mirror. So this is a convex mirror, right? So whenever a ray traveling parallel to this principal axis, so this is the principal axis in case of convex mirror. Okay. So whenever a ray is falling onto this convex mirror, what will happen? It will diverge, right? So whenever we are extending the reflected ray backward, it will pass in this way. Let us pass another ray onto this convex mirror. What will happen? It will also diverge in some other direction. Let us extend this reflected ray backwards. So what is happening here? The both reflected rays are meeting at one point. That point is called as focus in case of convex mirror. But what is the difference here? The difference is, in concave mirror, reflected rays are converging, that is, they are seen like they are coming into the focus. In this case, they are seen like they are going out of the focus. Okay, next point. All the rays that pass through the focus of the mirror, they will travel parallel to the principal axis after reflection. So what he is saying, whenever a ray passing through the focus hits the mirror, it will get reflected parallel to the principal axis. Okay, so this is the principal axis, right? So it will get reflected parallel to the principal axis. In case of convex mirror, it is also same. Whenever a ray is passing in this way, if you extend this line backwards, it will meet at point focus, right? So whenever a ray is falling onto the mirror in this direction, it will reflect parallel to the principal axis. Okay, so this is second point. Third point, a ray passing through the center of curvature C will retrace its own path after reflection. So what he is saying, this is center of curvature. Okay, so whenever a ray passing through the center of curvature falls on this mirror, it will retrace its own path after reflection. So what is happening here? The angle of incidence is becoming 0 and angle of reflection is becoming 0. Okay, why? Angle of incidence is equal to angle of reflection, right? So it will retrace its own path again. And in case of convex mirror, it is also same. We have center of curvature here. Okay, so what is happening in case of convex mirror? Whenever a ray is falling in this direction, if you extend it, it will also meet center of curvature, right? So whenever this ray is falling in this direction, which will meet the center of curvature, it will retrace its own path after reflection. Okay, next, a ray passing through the principal axis will reflect back along the principal axis. So what is happening here, whenever a ray travels through the principal axis and touches the mirror, it will retrace its own path, that is, it will reflect back in the same direction. This is same in case of convex mirror. Okay, whenever a ray is passing like this onto the mirror, then it will definitely reflect back in the same direction, that is, it will retrace its own path through the principal axis. Okay, so these are the 4 points to remember while drawing ray diagrams. That is, these are the 4 rules to be remembered while drawing ray diagrams. Okay, next, characteristics of concave mirror. So let us see what are the characteristics of concave mirror placing the object at different points. First one, object placed beyond center of curvature. So first let us draw the concave mirror. Okay, so this is a concave mirror, right? Let us draw the principal axis. Okay, here we have a pole, right? The midpoint of this mirror is called as pole, and we have a focus and we have a center of curvature, right? So what we are doing here, we are placing a object beyond center of curvature, that is after center of curvature. So let us say we have placed an object here. Okay, this is object. Now after placing this object, let us say a ray has fallen onto this mirror in this way. So what will happen? It will get reflected back, which will meet the focus. And say again a ray has fallen onto the mirror, but in this time it will pass through the focus and hit the mirror. So what will happen? It will get reflected, but it will be parallelly reflected. So what is happening here? Two reflected rays are meeting at a point. So at this point we are getting a image. So let us write the characteristics of this image. Okay, so what is the characteristics of the image? By seeing this only we can say one characteristics. The image is inverted, so we are getting the image as inverted image. Inverted in the sense the image is not upright, it is ulta. Next, it is diminished than the object. Diminished in the sense it is small, so it is smaller in size compared to the size of the object. Next, it is a real image. Real image ante enti? Real image is nothing but which can be caught on the screen, which can be seen on the screen. Next, it is formed between focus and center of curvature. So these are the 4 characteristics of the image when it is placed beyond center of curvature. Now let us see the characteristics of the image when it is placed at center of curvature. Again let us draw a concave mirror. So after drawing this, it will have a principal axis, right? So let us say this is pole, here we have focus, and here we have center of curvature. Now what we are saying, we are placing an object at center of curvature, right? Let us say a ray has fallen onto the mirror through this object in this direction. So what will happen, this ray will reflect back passing through the focus, right? After this, let us say another ray has fallen onto the mirror through the object passing from the focus in this direction. So what will happen, this ray will get reflected parallel to the principal axis. So here the two rays are meeting at this point. Here we got the image of this object. So this is object and this is image. What characteristics we can write from seeing from this ray diagram? The image is inverted, right? It is not upright, it is ulta. So the image is inverted. Next, the image height and the object height both are same, right? So they are equal in size. That is, the object size is equal to the image size. Next, it is a real image. It can be seen on the screen, right? Next, it is formed at center of curvature, right? The object is placed at center of curvature and image is also formed at center of curvature. So these are the four characteristics of the image when the object is placed at center of curvature. Okay. Next, object placed between focus and center of curvature. So let us draw the ray diagram first. So let us take a concave mirror. Okay, let us draw a principal axis and the midpoint of this mirror is formed as pole. Here we have a focus. This is the center of curvature. So what we are doing here, we are placing an object in between the focus and center of curvature. So let us say a ray has fallen from this object onto this mirror in this direction. So what will happen, this ray will get reflected back passing through the focus in this way, right, in this direction. Now let us say another ray has fallen passing through the focus onto this mirror in this direction. Okay, so what will happen, whenever a ray is falling onto the mirror passing through the focus, it will reflect it parallelly to this principal axis, right? So this ray will also get reflected parallel to this principal axis. Okay, so the two reflected rays are meeting at this point, right? So at this point the image is formed. So this is the image of this object. Okay, so what are the characteristics of this image when we are placing between focus and center of curvature? The image is definitely, it is inverted image, and second characteristic is the size of the image is more compared to the object, right? So the size of the image is enlarged ante the size of the image is more compared to the size of the object. Next, it is a real image. It can be seen on the screen. Next, the image is formed beyond the scene, right? So these are the four characteristics of the image when the object is placed between focus and center of curvature. Next, object placed at focus. So let us draw concave mirror. So this is a principal axis. The midpoint is called as pole. There is a focus and there is a center of curvature. So here what we are doing, we are placing an object on the focus. So let us say a ray from this object has fallen onto this mirror. So what will happen? It will get reflected back passing through the focus in this direction, right? So let us say another ray has fallen through the object in this direction. Okay, it will meet the center of curvature. So what is happening here? The two reflected rays are not meeting at any point. So what will be the characteristics of the image in this case? The two reflected rays are parallel to each other. So this is one of the characteristics. Next, what would be the next characteristics? They don't intersect. They are not intersecting, right? That is, they are not meeting. Next, so the reflected rays are not meeting at any point, so we cannot say that the image formed is real or virtual. Virtual ante the image cannot be seen on the screen. So in this case, we cannot say that the image is a real image or a virtual image. Next characteristic is, so we cannot say the image is virtual or real image, but we can say that the image is formed at infinity. Okay. As we cannot say the image is real or virtual image, we can say that the image is formed at infinite. Okay, so these are the four characteristics of the image when object is placed at focus. Okay, next, object placed between pole and focus. So let us draw a concave mirror again. So this is the pole, this is the focus, and this is the center of curvature. So what we are doing here? We are placing the object between pole and focus. Here, now let us say a ray from this object has fallen onto this mirror in this way. So it will definitely get reflected back passing through this focus point in this direction. Next, let us say a ray has fallen onto the mirror in this direction. Okay, so this ray will retrace its path passing through the center of curvature. So here let us extend this reflected rays backwards. Okay. So at this point we are getting the image. Okay. So this image is a virtual image. Okay. It cannot be seen on the screen. So the first characteristic of the image which is formed when the object is placed between pole and focus is virtual image. Second one is the image is enlarged. That is, the size of the image is more than the size of the object. Third characteristic is erected, that is the image is formed upright, so it is an erected image. So these are the three characteristics of the image when the object is placed between pole and focus. Okay, next let us see the characteristics of convex mirror when object is placed in front of it. Okay, so let us draw a convex mirror first. So let us draw principal axis. So this is pole, here we have focus, here we have center of curvature. So what we are doing here, we are placing an object in front of a convex mirror. So let us say we have placed an object here. Let us say a ray has fallen onto this mirror in this direction. So if you extend this ray backwards, then it will touch focus. So whenever a ray is falling on the mirror, touching the focus, then it will definitely reflect in parallel to the principal axis, right? So it have reflected parallel to the principal axis. Now let us say a ray has fallen onto this mirror which will meet the center of curvature when we extend it backwards. So whenever a ray is meeting center of curvature and falling on the mirror, it will retrace its own path after reflection, right? So it will retrace its own path. After that, let us extend the ray which have reflected parallelly to the principal axis. So let us extend this. So after extending, we got a point here, right? So at that point, we will get the image. So what will be the characteristics of the image? It will be virtual image, right? Next, the size of the image will be less than the size of the object. So the image size is diminished. Okay. Next, it will be erected. So erected in the sense it will be upright. It will be not ulta. The image formed will be upright as of the object. So these are the characteristics of the image formed when we are placing in front of a convex mirror. Okay. Next, mirror formula. So what is mirror formula? Mirror formula is nothing but it is 1 by f equal to 1 by v plus 1 by u. So what is f here? F is nothing but it is focal length. So what is focal length? Focal length is nothing but, consider this is a concave mirror, right? So here the midpoint of this concave mirror is pole, and here we have a focus, and here we have a center of curvature, right? So the length from pole to focus, this length is called as focal length. Okay, this length is called as focal length F. Okay, so 1 by F is focal length and V is image distance and U is object distance. Okay, so V is image distance and U is object distance and focal length is F. So this is mirror formula. So let us derive this formula. Okay, so this mirror formula is basically dependent on similar triangles. So similar triangles is nothing but where the corresponding sides are equal. Okay, for example, this is a triangle and this is one more triangle. So A, B, C, P, Q, R. So the both triangles have same shape, right? So the both triangles will become similar triangles and the corresponding sides of these triangles will be equal and the corresponding angles also will be equal. So AB by PQ equal to AC by PR equal to BC by QR and angle A equal to angle P, angle B equal to angle Q, angle C equal to angle R. So, in similar triangles, the corresponding sides will be equal and the corresponding angles will be equal. So, this is what we are going to use. Now, let us draw a concave mirror. Okay, let us draw a ray diagram. This is the principal axis, this is the pole, this is the focus, this is the center of curvature. So now we are placing an object beyond center of curvature. So just now we have learned the characteristics of image formed when we are placing an object beyond C, right? So let us say a light ray has fallen from this object onto the mirror. So it has fallen onto the mirror in this direction. So the reflected ray will definitely reflect back passing through this focus, right, in this direction. And again, let us say another ray has passed from this center of curvature and fallen on this concave mirror. So what will happen when a ray is passing through the center of curvature and falling on the mirror? It will retrace its own path, right? So it have retraces its own path. So where the two reflected rays are meeting, at that point we are getting the image, right? At this point we have got the image of this object. So this is the image V and this is the object U. Okay, so let us say this object is AB and the image formed is B dash A dash. Okay, so we have denoted this object as AB and the image formed as A dash and B dash. So now from this triangle ABC is similar to triangle A dash B dash C, right? What will happen? AB by A dash B dash will be equal to AC by A dash C, right? So let this be first equation. And next, let us draw a perpendicular line from this point. Let us say this ray is X, okay? So let us draw a perpendicular onto the principal axis from the X. Okay, so let us say this point is P dash, where this perpendicular is meeting the principal axis, that point be P dash. So from this you can say that triangle P dash XF is similar to triangle A dash B dash F, right? So where is triangle P dash XF? This is triangle P dash XF and it is similar to triangle A dash B dash F, right? Both are similar triangles. So what will happen in this case? P dash X by A dash B dash will be equal to P dash F by A dash F. So let this be second equation. Okay. So from this we can say that P dash X is equal to AB. So how we can say this? Simply the object size will be equal to this perpendicular line size, right? So we can say P dash X equal to AB. So now we can replace P dash X by AB. Right, so AB by A dash B dash equal to P dash F by A dash F. So let this be third equation. So in this third equation and first equation we have AB by A dash B dash common, right? So we can simply write as AC by A dash C is equal to P dash F by A dash F, right? So let this equation be fourth equation. Now if the ray is near to the principal axis, then we will consider that P dash coincides with P. So then what will happen? P dash F will be equal to PF. When P dash is coinciding with P, then P dash will be equal to P, right? So P dash F equal to PF. Then what will equation 4 becomes? AC by A dash C equal to, we will replace P dash by P. So PF by A dash F. So let this equation be fifth equation. Now by seeing the figure we can write AC equal to PA minus PC, right? And next A dash C equal to PC minus PA dash, and A dash F equal to PA dash minus PF. So by seeing the figure we can write this 3, right? So let us substitute this 3 in equation 5. So what is equation 5? AC by A dash C equal to PF by A dash F, right? So let us replace AC. What we have written, AC equal to PA minus PC, right? So PA minus PC by A dash C equal to PF by what we have written, A dash F. A dash F is PA dash minus PF, right? So let us write that PA dash minus PF. So let this be sixth equation. Okay. Now what is PF from the figure? Let us see the ray diagram. So what is PA? This is P and this is A, right? So what is this PA? This is object distance U, right? So PA is U. And what is PC? This is P and this is C, right? So what is the distance between PC called? It is radius of curvature R. So let us write PC equal to R. Then what is PA dash? This is P and this is A dash. So what is the distance between P and A dash? It is image distance V, right? So PA dash is V. And what is PF? This is P and this is F. So what is PF? It is focal length F. So PF is equal to F. And what is PC equal to R in the sense? PC is equal to 2F, right? So focal length is half of radius of curvature. So what will it will be? Radius of curvature will be 2F, right? Now let us substitute these things in equation 6. What you will get? U minus 2F divided by 2F minus V equal to F minus V minus F. So let us solve this equation. Okay. What you will get? V minus F into U minus 2F equal to F into 2F minus V. Vu minus 2Vf minus Uf plus 2F square equal to 2F square minus Vf. So let us keep this Vu to this side and take all the things to other side. What you will get? Uv equal to 2F square minus Vf plus 2Vf plus Uf minus 2F square. So 2F square get cancelled and you will get Uv equal to Vf plus Uf. So let this be seventh equation. Now let us divide seventh equation with UVF. Okay. UV by UVF equal to VF by UVF plus UF by UVF. So UF gets cancelled. In this VF gets cancelled. In this UV will get cancelled. So what you will be left over with? 1 by f equal to 1 by u plus 1 by v. So this is the eighth equation, which is the mirror formula. So this is the mirror formula. So f is focal length, u is object distance, and v is image distance. So while using this, we have to use sign convention in every case. So what is sign convention now? Sign convention is nothing but, so we have some rules to measure the distances. That is, all the distances should be measured from the pole. So let this be a concave mirror, right? So this is a pole, right? So every distance must be measured from the pole, okay, in this direction, okay. And next, distance is measured in direction of incident ray should be taken positive, and distance is measured opposite to the direction of incident ray should be taken negative. So what is incident ray here? Consider here is an object. So a ray is falling onto this mirror through this object. So this ray will become incident ray, okay. This is a incident ray. So the distance is measured in this direction, in this incident ray direction will taken as positive, and the distance is measured in opposite direction, in this direction, that distances will taken as negative, okay. Next, height of the object and height of the image are taken positive if measured upwards from the axis, and negative if measured downwards. So what is axis here? So the height of the object will taken as positive when it is measured upwards in this direction. This is the axis, okay. In this direction, if we measure the height of the object, it will be taken as positive. Same for image also. And if we measure the height of the image or the object in this direction, that is downward direction, then they will taken as negative. So these are the three sign convention rules, okay. So while using mirror formula, we have to observe these 3 points, okay. Next, magnification of spherical mirror. So magnification is nothing but it shows us the changes of size of images, okay. And magnification is also stated as relation between object distance and image distance. That is, magnification is denoted with the letter M, and object height and image height is Hi, and object height is H naught. Magnification is equal to Hi by H naught, that is V by U minus V by U. So V is image distance and U is object distance. So magnification is nothing but it is the relation between object distance and image distance. It just shows us the changes in the size of the image, that is changes in the length of the image, okay. So this is magnification. Next, uses of concave mirrors. Concave mirrors are used by dentists to check the teeth, okay. They use the concave mirrors to check our teeth. And next, they are used in microscopes. They are used in shaving mirrors, and they are also used in preparation of solar cookers. Next, uses of convex mirrors. So convex mirrors are used as rear view mirrors in vehicles. So we have rear view mirrors in our vehicles, right? So they are made of convex mirrors. Next, they are used at the junctions of the roads. So they are used at the junctions of the road so that we can get a far view. And next, in the shopping malls at parking areas. Next, at curved roads. Okay. So these are the uses of concave and convex mirrors. So if you don't know what is real image and virtual image, we can write simple differences for real and virtual image. Okay. First one, it is inverted image. Real image is inverted image. Okay. Virtual image is erected image. So erected is, it is upright image, and real image is inverted image, that is it will be ulta of the object, okay. Next, real image can be caught on the screen, okay, and virtual image cannot be seen on the screen, okay. Next, real images can be formed only by using concave mirrors. So it can be formed only by using concave
mirrors. Okay, but virtual images can be formed by using both mirrors, that is concave and convex. Okay, next, these real images can be formed by reflected rays in the ray diagrams itself, right? But we are extending the reflected rays, by this only we are getting the virtual images in convex mirror case, right? So virtual images are formed by extending the reflected rays backwards. Ray diagrams. So these are the basic differences between real and virtual image. So by this we have completed the first chapter, that is reflection of light at curved surfaces. So I hope you all understood this one short session and I have briefed each and every topic. So I hope you have understood each and everything. If you have any queries, please do comment me in the comment box, and please like, share and subscribe to my channel, and let us meet in another amazing one short session.